They used to say the ocean was an unbreakable fortress of life, a vast realm immune to human folly. But now, that fortress is showing cracks, and the Argo program is stepping in to reveal every hidden fracture. With those words whispered amid the hustle and bustle of the Third United Nations Ocean Conference, we open our eyes to a planet whose watery expanses are under greater scrutiny than ever before. Today we plunge into one of the most thrilling and monumental undertakings in modern oceanic exploration. A vast network of floats that patrol the seas, gathering data from the surface to depths so immense that the pressure could crush standard research gear in seconds. So, what is happening down there, beneath the waves, and why should anyone on land care about it? Today we will unravel the secrets of the Argo program, a once small set of robotic instruments launched in the early 2000s, now evolved into the audacious OneArgo initiative. From acidifying waters encroaching on marine life to oxygen depletion zones that threaten entire ecosystems, the ocean is transforming, and the Argo floats are here to show us exactly how. In this journey, we will explore the fearless technology that drives OneArgo's mission. We will scrutinize how these seemingly unremarkable floating cylinders quietly embark on voyages across the vast wilderness of open water, collecting data that can make or break our understanding of global climate. We will also peer into the future. Can OneArgo truly become fully operational by the year 2030? What modifications will it make to the original concept of Argo? And ultimately, how will the real-time data from these roving high-tech sentinels help us see what might be lurking around the corner for our planet's largest ecosystem? We will dive into the gritty details of how these floats gather information on temperature, salinity, pH levels, and vital parameters like chlorophyll and nitrate concentrations, painting a dramatic picture of an ocean that is more dynamic and more vulnerable than we ever imagined. Sound exciting? Well, get ready, because we will also chart how the brand new OneArgo has already begun, with 500 specialized biogeochemical floats and 200 deep floats deployed, even as you watch this video. Meanwhile, they are forging ahead to meet the ambitious goal of deploying more than 4,000 floats in total. This is just the beginning. Perhaps you are wondering, is this purely a scientific pursuit, or does it have practical implications in my everyday life? If you suspect that ocean monitoring touches on pressing issues like climate change, marine biodiversity, and even global weather patterns, you are absolutely correct. In fact, the stakes are high. Everything from the fish on your plate to the intensity of the next hurricane can be influenced by the ocean's subtle changes. By the end of today's deep dive, you will see how Argo data is serving as a navigational compass for policymakers, environmentalists, and everyday citizens who want to ensure we leave a healthy planet for future generations. In this episode, we will delve into some of the core controversies sparked by these findings. As the floats transmit real-time data about increasing acidification, certain industries and governments may be forced to acknowledge uncomfortable truths. We will talk about why some coastal economies are thrilled to have these robust data streams, while others might be quietly uneasy that the numbers could reveal negative impacts on fisheries and tourism revenue. This tension underscores the crucial role of transparency in scientific research. The results, whether encouraging or alarming, cannot be hidden once the data beams to satellites and is made available to institutes all across the globe. But do not worry, this is not just a cautionary tale about environmental doom. This is also the story of human ingenuity at work. In the early 2000s, launching Argo was seen as overly ambitious. Critics questioned whether we really needed to monitor thousands of floating robots, drifting at the whim of ocean currents. Yet time proved those critics wrong. Over the past 2 decades, the initial wave of Argo floats has revolutionized our knowledge of ocean circulation and heat exchange, unlocking the hidden heartbeat of our planet's climate. The very fact that the new iteration, OneArgo, is now poised to take ocean monitoring to extraordinary new depths and more comprehensive coverage is a testament to how indispensable Argo has become. Imagine these robotic explorers gliding along, measuring salinity, temperature, carbon dioxide concentrations, and even pH levels in the darkest corners of the ocean. Some of these specialized floats can dive as far down as 6,000 meters. That is almost unimaginable pressure and darkness, realms where sunlight never shines. And yet it is there that some of the most significant climate shifts may first be felt. Because if we cannot determine what is happening in the deep ocean, how can we possibly predict sea level rise, changes to marine habitats, or overarching global temperature trends with any accuracy. We will examine how the Argo floats transmit their data. Picture this. They start by drifting passively at a certain depth, then periodically pump oil from an internal bladder, becoming either more or less buoyant. This controlled buoyancy shift allows them to ascend or descend. Once they reach the surface, they beam their newly harvested knowledge via satellite back to mission control. Then they sink again, continuing their ceaseless vigil. In this manner, the floats gather comprehensive snapshots of our oceans, snapshots that scientists from Antarctica to Zanzibar can access, interpret, and incorporate into climate models. These advanced models, in turn, predict everything from monsoons in certain hemispheres to the severity of coral bleaching episodes. Now, let us talk about expansions and lofty goals. Argo began with far fewer floats, primarily measuring temperature and salinity in the upper 2,000 meters. The OneArgo plan is to maintain and enhance the original array while adding new instrumentation that captures data deeper into the abyss. By 2030, the initiative aims to have a grand total of 4,700 profiling floats, with about 1,000 dedicated to measuring crucial biogeochemical properties, and another 1,200 going to the darkest reaches of the ocean floor. If that does not seem like an impossible aspiration, consider the sheer logistics. Building these new generation floats to withstand the crushing pressure at 6,000 meters, deploying them far out at sea, and maintaining communication capabilities across every oceanic region. It is daunting, yet the OneArgo team believes it is not only realistic, but absolutely necessary. Of course, this type of large-scale scientific project requires funding, international collaboration, and unwavering commitment. You might ask, where does this money come from? And how do multiple countries spanning the globe coordinate seamlessly on such a massive project? The answers can be as complex as the data the floats collect. Various nations, marine research institutes, universities, and philanthropic organizations pitch in. They must agree on deployment schedules, data sharing protocols, standardized calibration methods, basically everything needed to keep the program operating effectively. This coordination is no small feat, but is crucial if the data is to be universally credible. Here is another question you might have. Why the sense of urgency? Can we not just wait and see what happens to the ocean over the next several decades? In a word, no. Scientists worldwide emphasize that each passing year without comprehensive ocean monitoring equates to gathering incomplete baseline data about marine ecosystems. We cannot diagnose issues like ocean acidification, oxygen depletion, or significant shifts in currents unless we have precise and continuous measurements. Consider how critical the ocean is for absorbing atmospheric carbon dioxide and regulating global temperature. If the ocean's capacity to buffer climate change is diminishing, we need to know about it now, not in 30 or 40 years when irreversible damage has already set in. To keep you engaged, let us highlight a few real marvels uncovered by Argo so far. One major discovery was the role of intermediate depth water masses in storing heat, a revelation that has refined climate change models dramatically. Another was the uncovering of subtle changes in salinity patterns that correspond to shifting rainfall and evaporation trends, a sure sign that what happens in the sky is intricately connected to what swirls beneath the waves. Then there was the discovery of deep ocean warming in regions once presumed stable. Events like those have guided everything from fisheries management to urgent discussions about how coastal communities can best prepare for rising sea levels. And each year, as more data accumulates, we become better at spotting the patterns behind such phenomena. In short, these floating guardians are not just beacons of scientific curiosity. They are safeguarding the future of communities around the world. They do so by offering a lens into the cyclical rhythms that drive hurricanes, upwellings, and the oceanic conveyor belt. We know now that ocean deoxygenation can threaten crucial fish stocks and lead to enormous dead zones where marine life can scarcely survive. We also know that acidifying waters can hinder the formation of shells and corals, thereby undermining entire ecosystems. Yet armed with the accurate information provided by the Argo floats, policymakers can propose measures to protect or restore biodiversity hotspots. Scientists can improve predictive models about hurricane intensity, and we can all make more informed decisions about energy usage and resource management. If you are feeling a spark of curiosity about how these discoveries come to life, go ahead and share that excitement. If you think more people need to know about the OneArgo program's incredible research, feel free to tap that like button so others realize they might be missing out on a vital piece of the climate puzzle. This is our first gentle invitation to show some support for this global scientific effort. Now, let us switch gears a bit and look at the current state of OneArgo deployment. While the entire plan envisions thousands of sophisticated floats, the initial wave of these new units is already functional. So far, the program has deployed about 500 BGC floats, short for biogeochemical floats, and 200 deep floats, which are specialized for those 6,000-meter descents. Though these numbers might seem modest compared to the final goal of thousands, they represent a major stride forward. Each float that is successfully launched becomes part of an ever-expanding digital net, continuously scanning the ocean's vital signs. As for the data, fields such as pH, chlorophyll concentration, oxygen, nitrate, and light levels can now be sampled alongside the more traditional temperature and salinity measurements. When you combine these factors, a story unfolds about what is happening at the surface and deep below, how life thrives or struggles in certain zones, and how the ocean's chemistry might be shifting in response to atmospheric changes. In areas where historically there was very little observational capacity, OneArgo's presence is already casting new light on phenomena we barely grasped in the 20th century, let alone the distant past. You might be thinking, but the ocean is so vast, with swirling currents and extreme depth variations, can we ever hope to gather enough data? That is indeed the challenge, but the unstoppable momentum behind OneArgo suggests that while we might never gather all the data, we will gather enough to see the overall trends and anomalies. That can be the difference between responding effectively to impending ecological crises and remaining in the dark until it is too late. Plus, it is an evolving platform. As new technology emerges, the program can incorporate advanced sensors, more robust satellite systems, and improved methods of data analysis. In some respects, OneArgo is not just an oceanic project, but also a template for how international collaboration might tackle other urgent challenges, from deforestation to space garbage. Naturally, the question of how to use these mountains of data once they are collected is equally important. That is where robust data management systems come into play. Leading oceanographic institutions compile, validate, and store the information, making it accessible to authorized researchers as well as the public. Because it is freely available, small projects, local governments, and independent researchers can glean insights, which fosters innovation. This democratization of knowledge ensures that you do not need a massive budget or a membership in an exclusive club to analyze or interpret Argo data. All you need is the curiosity and expertise to evaluate it critically. But let us not forget that this data can sometimes yield results that various industries or interest groups may find uncomfortable. For instance, if the data consistently reveals low oxygen zones encroaching upon prime fishing grounds, or a disturbing rate of ocean acidification compromising shellfish reproduction, it could spark heated debate about habitat conservation, greenhouse gas emission reductions, and the future of coastal economies. The important takeaway is that without Argo, many of these issues could go unseen until their impacts became devastatingly obvious. We also have to talk about how OneArgo's deeper coverage stands to reshape our understanding of the ocean floor. Historically, collecting in situ data from extreme depths, such as 5,000 or even 6,000 meters, was next to impossible on a large scale due to the cost and technical challenges. But with deep floats that can endure the pressure of those crushing depths, we can finally see how processes in the Hadal zone, the deepest region of oceanic trenches, influence phenomena higher up in the water column. We will learn whether pockets of warm water near the seafloor accelerate the melting of polar ice shelves, or how newly discovered ocean currents at depth might connect ecosystems across entire ocean basins. Meanwhile, for those of you who love a bit of behind-the-scenes intrigue, consider the tales of researchers braving harsh conditions to deploy these floats in remote corners of our planet, from rough seas in the Southern Ocean to the scorching heat near the equator. Each deployment is a technical dance that demands careful calibration, constant communication with the research vessel, and thorough checks to confirm the float is operational before it is gently released. Once activated, the float begins its life in one of the most challenging environments imaginable, yet it drifts with quiet perseverance, collecting data that could shape the fate of our coastal cities, our fisheries, and even the climate of the future. One might wonder, is there any competition or rivalry about collecting the biggest share of data? Indeed, certain nations might disagree over the best approach. Some regions pose political complications for research vessels, but for the most part, there is broad consensus that the ocean transcends borders. Environmental threats do not stop at a maritime boundary, so the impetus to cooperate remains strong. This synergy is what's powering OneArgo forward, ensuring that the data belongs to everyone and that the ocean is viewed as a shared heritage. Let us also highlight how the data are used in real-time forecasting. If a massive El Niño event is brewing in the Pacific, the Argo floats can detect shifts in temperature and salinity that might herald its arrival. Meteorologists and climate scientists can then refine their predictions of upcoming storm activity, droughts, or floods. That early warning means communities can better prepare. Over time, as the network expands, the resolution and accuracy of such forecasts stands to improve dramatically. Imagine being able to anticipate anomalies in monsoon rains or the onset of coral bleaching events. This means fewer surprises, less economic disruption, and a fighting chance for susceptible marine habitats. Now, if at this point you are thinking, wow, this is mind-blowing stuff and I want to be part of this global conversation, we encourage you to do one more thing. Subscribe or follow so you do not miss any further revelations about the planet's largest ecosystem. Let's face it, the ocean connects every continent, influences your daily weather, feeds billions, fuels commerce, and sequesters carbon. So here is our second call to action. Stay connected, stay informed, and help us ensure that knowledge about the ocean's state spreads far and wide. Still, the grand question remains, how do we weave all this knowledge into effective policy and meaningful action? That debate is unfolding on the ground at the Third United Nations Ocean Conference and related global gatherings. Nations bring forward policy proposals. Some push for stronger regulations on plastic pollution and greenhouse gas emissions, while others are more cautious, noting the economic sacrifices that certain measures might entail. The Argo data cannot provide all the answers, but it can highlight the ocean's response to existing policies, thereby pushing more leaders to see the bigger picture. If the data shows continuing acidification in areas we expected to be stable, for example, that is a huge red flag that more drastic steps might be needed. Many participants, from small island nations to coastal superpowers, share an understanding that without robust information, it is nearly impossible to know which climate solutions are working and which are not. OneArgo stands as a testament to humankind's collective ability to cooperate in the face of overwhelming challenges, blending technology and collaboration on a scale the world has rarely seen. Yes, there are logistical hurdles, funding obstacles, and plenty of political friction along the way, but the impetus is so strong. People are beginning to realize that the ocean is not infinite nor invulnerable. It is an irreplaceable life support system. Argo's next decade, culminating in 2030, promises to be a turning point, not just in how thoroughly we measure the ocean, but in how we interpret and apply that knowledge. The once far-off dream of a truly global and continuous ocean-observing system is inching closer to reality. Innovations in float technology will push the boundaries even further, offering new insight into the ocean's hidden layers and perhaps even tracking elusive phenomena like internal waves in the darkest trenches. Meanwhile, the data streams will remain open, encouraging a new generation of scientists, technicians, policymakers, and yes, even curious citizens like you to jump in and analyze the results. We have come a long way since the first Argo floats were tossed into the sea with limited sensors. Now we see an impressive array of new floats with biogeochemical pods that measure oxygen, chlorophyll, nitrate, and more advanced variables, while deeper models traverse parts of the ocean few have dared to explore. These developments enrich our knowledge exponentially. Each float's journey and each sampling cycle helps refine our view of ocean health. Keep in mind that the ocean has always been central to human stories, from ancient myths to modern shipping lanes. Only now, the urgency has escalated. The fate of the ocean is inextricably tied to our climate, food security, and the biodiversity that underpins natural processes everywhere. Understanding that fate was once guesswork, reliant on scattered data from research vessels or remote sensing satellites that can only skim the surface. But the Argo program is like the eyes, ears, and even the heartbeat monitor, stationed both at the surface and in the abyss. As the final decade leading to 2030 unfolds, you can expect OneArgo to ramp up once again. bridging knowledge gaps across mid-latitude gyres, equatorial currents, polar seas, and boundary regions near continents. Who knows what secrets remain in the swirling blackness below? Will we discover hidden pockets of warming or unexpected freshening events that challenge our climate models? Will we confirm some dire predictions about ocean acidification, or maybe observe areas that recover faster than expected after targeted conservation initiatives? The story is far from over. Yet for all the complexities, the message reverberating through the Third United Nations Ocean Conference is refreshingly simple. We need to understand the ocean to protect it. And to understand it, we must measure it accurately. That is the mandate behind Argo, behind OneArgo, and behind the wave of scientific excitement that is cresting right now. With each data packet that arrives from one of those floating robots, we gain a small but vital piece of a planetary-scale jigsaw puzzle. Remember, it is not just puzzle solving for fun. We are solving it to ensure generations to come have a stable planet, replete with the wonders of marine biodiversity and balanced climate systems. So, next time you glance at an ocean horizon, picture hundreds of unseen guardians silently drifting beneath the surface, measuring, recording, and sending back signals that could help preserve that horizon's future. This is the frontier of ocean science, open-ended, collective, and brimming with hope, even in the face of daunting environmental changes. And who knows? Perhaps the data they collect will shape the blueprint for everything from coastal city defenses to the far-reaching policies that might curb greenhouse gases and bring swathes of coral reefs back from the brink. There you have it. The Argo program's dramatic evolution into OneArgo is far more than just another scientific initiative. It is an urgent mission to document our changing ocean in real time, shining a spotlight on the interplay between human activity and Earth's marine environment as never before. Now, as these new floats continue to deploy and gather data from the deep, the big question is whether we as a global community can muster the will, the resources, and the imagination to use that information to safeguard the most monumental frontier on our planet. That, my friends, is the story we will continue to share. May it spark your imagination, stir your concern, and drive you to connect with others who wonder about the fate of our blue planet. Because at the end of the day, the ocean story is our own,